Hello friends, welcome to our channel KEKULE'S. Today we are going to discuss the VSEPR theory, that is valence shell electron pair repulsion. This theory explains the shapes of covalent bond, as I told earlier in the previous part, that none of the theory can explain complete characteristics of covalent bond. There are million trillions of compounds in chemistry which form the covalent bond, and their characteristics and behavior are not complete explained by a single theory. Already we did the Lewis theory. Lewis theory does not give any idea about the shape of the molecule. When we draw the H2O molecule with the help of Lewis structure, we take oxygen as central atom, hydrogen as the surrounding atoms. First we allocate the shared pair of electrons from both of the sides. This is what we do while writing the Lewis structures. This is a part of writing the Lewis structure. First we place the shared pair of electrons. After that a bond is formed. If they complete their octet, then we will draw the lone pair. This is whole about the Lewis structure. This Lewis structure does not explain the shape of the molecule. The two scientists named Gillespie and Nylonen predict the shape of the molecule when the atoms link together by a covalent bond only. In the light of this VSEPR theory, the actual shape of H2O molecule is not in this way. The actual shape of H2O molecule is basically drawn in this way. Why this is having this kind of shape? It is because, as in the light of this chapter, the two scientists gave a order of repulsion attraction, which is as follow, that the lone pair is having more repulsion than that of lone pair, bond pair having more than bond pair. The group of two atoms is known as lone pair. This one is called bond pair, this one is called lone pair. The atoms which are not participating in covalent bond, these atoms are not participating in covalent bond, so these electrons are known as lone pair. So how many lone pair oxygen has? Oxygen has two lone pair. Oxygen is having the two lone pair. And how many shared pair of electrons? Oxygen is having the two shared pair of electrons. So according to this theory, the shape of H2O is bent. What is the purpose of this theory? This theory explains the definite arrangement of bonded atom in a covalent bond, which we called it as geometry of molecule. This VSEPR theory predict the shape of molecule which are bonding together. So what we are doing over here, we are just predicting the shape of H2O molecule which is not told by the Lewis structure. When we talk about this structure, this molecule is having bent structure because there are two lone pair are present on the central atom named oxygen. This lone pair has more repulsion than that of lone pair and bond pair. I'll repeat again that lone pair is having more repulsion than lone pair and bond pair. What is existing between these two? This is lone pair, this is bond pair. And what is existing between these two? These are having lone pair. So lone pair attraction is more then that of lone pair and bond pair, and this one is also having the bond pair interaction, which means repulsion. So because of this order decides the geometry of the covalent molecule, whether it is a regular or irregular. What does regular means? Regular means, as we do in the mathematics, that the regular means which is having which we can name that geometry. It may be a linear, it may be a trigonal, it may be a tetrahedral. If we give the name to a particular geometry, we call it as regular. If we not give the name of that geometry, we call it as irregular. So when we talk about the overall whole VSEPR theory concept based on this order, when we say a molecule is surrounded, a central atom is surrounded by a bond pair only, we call bond pair, this is bond pair, or we call it as shared pair. Both are having the same meaning. When we say bond pair or shared pair, both are having the similar meaning, need not to be confused. When we say a central atom is surrounded by, when a central atom is bounded by only a shared pair of electrons, it means that none of lone pair is present, only shared pair of electrons. Then as a result, we call these as regular geometry. When we say regular geometry, when there is no lone pair, when there is no lone pair is there, when there is no lone pair, we call it as regular geometry. However, the actual geometry depends upon shared pair the shared pair. When we are having the two bonded atoms, we called it as linear shape. Just remember this table. The book you are using for this chapter, a table is given in that book. You can see that table. When three shared pair, we are talking about the shared pair only. Shared pair. This is a part of regular geometry. We are just discussing the regular geometry. After that, we will be discussing the irregular geometry, and after the whole explanation, we will discuss how to predict the geometry. Few examples that how to predict the geometry. When there is three shared pair of electrons, we call it as trigonal. What is the shape of trigonal? Planar. This one is the shape of trigonal. Remember this point, that the regular geometry is having the no lone pair. When you are having the four shared pair of electrons, it means we are having the shape of tetrahedral. This one is having the tetrahedral shape with no lone pair. When we are having the 5, then we called it as trigonal pyramidal. Trigonal by pyramidal. The shape is somehow like this. Yes, this one is the actual shape of trigonal pyramidal. Just remember this kind of shape. Okay, these are the part of regular geometry. When we say a lone pair alongside with the shared pair, both are given to us, then we will call this as, both will repel each other because lone pair is also made of electrons, shared pair of these are also a part of electrons. So negative repel each other. So we call it as lone pair bond pair interaction. So both will repel each other. This repulsion can cause the change in the shape. change in the geometry. When both lone pair and shared pair of electrons are given to us, we call it as irregular geometry. Irregular geometry. I'm going to list here few. You can also look into your book. When two bond pair given to us, bond pair, lone pair, when two bond pair given to us and one lone pair is given to us, then it's a type of molecule. What type of molecule it is? What's its type? It will be A for central atom with bond pair 2, lone pair 1. We call it as AB2L. And this type of geometry is having a shape of bent. How we can draw the geometry? Lone pair is present. These are shared pair of electrons. We call it as bond pair, as I told earlier that these are two bond pair and one lone pair. We call this shape as bent, and arrangement and expected geometry to be trigonal planar. When we are having the bond pair and lone pair of 3 bond pair, 1 lone pair, we call this kind of geometry with a central atom bond pair as 3, lone pair as 1. This type of geometry is having the tetrahedral. What is the shape of tetrahedral? Remember this shape. Remember these shapes. I will place a lone pair with 3 bond pair, 1, 2, 3, and a 1 lone pair. This type of shape is, we called it as, actual shape named as pyramidal. Actual shape is known as pyramidal. This is having the, now if, don't need not to worry about this table. This table you can search on the internet, or you can, or the book you are using has this table. Okay, when we are having the 2 bond pair, 2 lone pair, we are having a type of AB2L2, bond pair, lone pair, 2, 2. So when this type of geometry comes, we again called it as tetrahedral, and this type of shape is, we called it as bent. So what is the shape of water over here? Is bent. So it is similar type. This is having the 2 lone pair, 2 bond pair, 2 lone pair, 2 bond pair. This type, what is the type of molecule? It will be AB2L2. AB2 bond pair, lone pair, L2. So what is the shape? I already drawn it. This is the shape of the AB2L2 molecule. Why this shape is bent? Because lone pair will repel each other. It is having the more interaction, it is having the more repulsion than that of lone pair bond pair. If I am having the next type is AB4L, that is 4 bond pair, 1 lone pair, then its shape will be trigonal pyramidal, or we can say seesaw shape. How seesaw is formed? This one is the shape of seesaw. This is whole about the VSEPR theory. This is whole about the VSEPR theory. This is whole about the, we have to just learn these 2 types of geometry, regular and the irregular geometry. We call the shape of this water as bent or angular. This one is the important part. Now we are going to discuss how to predict the shape of the geometry. Here we are going to discuss the geometry of chlorine and fluorine molecule, where number of overall 3 fluorine atoms are contributed. Since we know that the chlorine is having the 7 valence electron, by writing the configuration as according to the Bohr model, that is 287. When we write the 287, it means 7 valence electron will participate in forming the shape of the molecule. And the 3 fluorine atoms, how many fluorine atoms? Each will, fluorine is having the, this one is chlorine, this one is fluorine, 2, 7. Both want to complete their octet by sharing their electrons, because both are acting as non-metal. Both want to complete their octet by contributing their valence electrons. The chlorine is having the valence electron, 7 valence electron, alongside how many fluorines are present? 3 fluorines are present. So it will contribute 1 electron because they want to complete their octet by sharing 1 electron. So we can say 7 plus 3, it will be equals to 10. 10 electrons are present in the molecule which are going to form a shape. So how many pairs are present divided by 2? 5 pairs are present. 5 pairs are present. So number of shared paired electrons, shared. 3 fluorines are present, so they will share the 3 electrons. Number of lone pair electrons left behind will be 2. 5 pairs are present, 3 plus 2, 5. Share 3 fluorines are present, so 3 pair will be shared by the chlorine. 2R, so it is a type of molecule A, B, shared paired AB2, L3. So this type of molecule is having the, T shape. AB3, L2. Shared pair bond pair, we also call it as shared pair. Shared pair is 3, AB3, L2. When this type of molecule is given to us, we call it as T shape. So, but this is what we can predict this is how we can predict the shape of the molecule. Another example, we are having the bromine with the fluorine molecule, where fluorine is having the 5 fluorine is interacting with the bromine. Bromine is having the configuration same as that of chlorine, that it is having the 7 valence electron. So bromine has 7 valence electron and 5 contributed by the fluorine atoms. So total number of valence electron is 7 plus 5, so which is equals to 12. How many pairs are present? 6 pairs are present. 5 fluorine are present, so 5 will acting as a shared pair of electrons shared by the fluorine. 1 is left behind. We called it as lone pair. So it is a type of A. Bond pair is 5, AB, 5, L2. If you see your chart given in your book, and then the shape of the molecule will be square pyramidal. Square pyramidal. We can draw this shape as fluorine. 3 fluorines are present, 5 fluorines are present, so we can draw 5 fluorines. Okay, so how many? 4 are already completed, so 1 fluorine is over here and 1 lone pair. So we can draw, this is the shape of this B. What about this shape? This is having the 2 lone pair, so we will draw this. This is the shape of, we call it as T shape. So this is all about predicting the shape of the molecule.